Hello guys, today let's discuss about depth first search in a matrix. So let's start guys. By seeing the definition means the words depth first search, we can see that we are searching in a depth in anything. So today I'll discuss about depth first search in a matrix. In another video I'll discuss about depth first search in a graph. So let's start guys. See, basically what is depth first search means. We are searching in depth. So see this is a graph. This complete thing is a graph, right? Everything is graph. Even these two and this one, everything is the same graph, right? Now, what is DFS means? If we start from a single node, it iterates through every node, right? Means that is DFS. If you want, you can check for DFS in a graph actually. If we start from a node, we are searching through every node. If we call this one, this calls this one. From this one, this adjacent, so it calls this one and this one. Uh, Nothing is there here, so it returns back. It calls this one, so this calls this one, and this calls it goes. It searches through every graph, means every node in the graph. So obviously here this one should go and this one should go, right? So basically, what I am saying is DFS means we're searching through depth, searching through levels. In a graph, basically, you can search in online or internet. Basically, if you type DFS, you will get DFS. So, but today I'm discussing about DFS in a matrix. So let's start, guys. So basically, basic DFS you are understood, right? See, if I start from this node, it iterates, it searches every node by depth. By depth means it calls adjacent node. Two's adjacent is two members, right? So first it calls one member, it it holds the stack space, then it calls second member. So it calls three, but three nothing is there, so it returns. It calls the second member, again four, again five. So like that, DFS in a graph. You can check it in online. So now let me discuss DFS in a matrix. So this is a matrix. So basically, what the question is, we have to find means we have to find number of suppose he given this one this node, we have to find number of ones in this one, right? See, if we give this one, we have to find connected components. Connected components means not connected components. Every this block we have to find means adjacent is one, right? So this adjacent is one. This adjacent ones like that. Every we have to find this one number of elements in this one. For this one, we can use DFS, right? Means what is DFS? Searching adjacent elements in a depth-wise manner, in a level-wise manner. So let's solve it, guys. Let's understand the logic first. So one, we'll go to the adjacent. We'll go to the adjacent. Let me decrease the font size. Arrange this one. So it goes this like this one. Now this DFS. For this one, DFS means this one, right? Adjacent, right? For this one, adjacent means this one. So like this, we are going on, right? Let me write a function to function and code to this one. Function. Let me add a function and code this one. So for function, let me for this one you should know recursion very good, guys. You should learn recursion perfectly. You can watch in online or anywhere recursion. So let's check this. Let's see this one. Uh, DFS of ij. Ij means I am giving index I and j. See, suppose this node is there. If I gave index 0, comma 0, it should iterate every node and tell me the maximum number of blocks in this one. Like that, I am writing DFS. I'm writing a function DFS in that. So let me do this. DFS of ij. Suppose 0, comma 0 is given. Now what it will do? Now what it will do is calling it reverse DFS means we are doing it through recursion, right? So what I will do is DFS calls this is 0 0. What it will do? It calls another function DFS of I comma j. Same function, but I plus 1, I plus 1. Again, it calls the same function means same function means similar, but j plus 1. Four directions, right? Again, this one. Again, it calls. Now, I minus 1. Four directions, right? I'm checking it four directions. I will tell you. 1 minute. I minus 1 and here j minus 1, right? So this calls, if I put it in middle, four functions, right? One, two, three, four. Means I will call like this. See, if zero, if anywhere, suppose I told here, I took here one, but if I take here one, four directions are possible, right? So what it will do is DFS of I plus 1 and j means again means this one will come, right. I plus 1 means 0 plus 1. 0 plus 1 means 1. So this will come. Now what it will do? DFS of I plus 1 is 1. Again it will call 4 calls, right. 4 calls. This one again 4 calls. Again 4 calls. Again 4 calls, right. This one 4 calls. What will be these 4 calls? DFS of I plus 1 is any number will be there. Suppose I naught. What will come? I naught plus 1, comma j. Okay. How was this j naught? So I naught comma j naught plus 1 and I naught minus 1 comma j naught and I naught comma j naught minus 1. Suppose here I1 is there. I1 plus 1 j1. Like that, 4 calls, right? But when this calls, let me tell you properly, this is a recursion call, right? So when this call runs, it means it calls this one also. But after this completing means after, see, let me tell me carefully. Let me use green, no green. See, first it will call this one, this one. After this one, it will call basically call four means four functions means opposite left right opposite down. But first this call will go means first in code which line is there that line will go means in code this one is there DFS of I plus 1 comma j. First this one will go here. It will execute this one. After executing this one, it will go this one. After executing this one, it will go this one. After executing this one, it will go to the next call. After completing these four functions, if completing this one, it will return backtrack. Recursion, guys. You have to see recursion. You have to know recursion. After this one, if it returns, if it hits the base case anywhere, it will return. If it hits the base case anywhere, it will return. If it hits the base case anywhere, it will return. After completing this function, it will return, and after that, it will go to this function. Like that, it will call the functions, but it will hold the stack space. If there is stack space, it hold first this function. After this function, only next one. Like that, it holds the stack space, and so this is the basic idea, guys. Let me give you a basic code, basic idea code. So for that one, um, I'll put the code in the means general code. I'll give you a general code. So for general code, let me write. So DFS of I comma j is there. Otherwise, I'll give you general code in the description or comment section. Let me solve this question, guys. Means for a basic understanding, let me solve this question. I will give this code in the description. Uh, Maximum area of island. Maximum area of island means DFS. We can use basically DFS only. See, let's read the question. You are given a matrix uh, of an island of group ones representing connected four directionally horizontal vertical. You may assume the four edges of the grid are surrounding by water. The area of the island is the number of cells with value 1 in the island. Return the maximum area of the island in the grid. If there is no island, return 0. Okay. So basically what he is telling is you have to find the maximum area, right? See, this one here. Here, uh, here it is there. Uh, Same DFS, we are traversing everything. We have to return the maximum area. You can consider this as an island. We have to return this area, which number of ones in it. Like that, here in this example, it is 11, but in another example, it can be anything. So using DFS, we will do it in the next video. There I will give code also. So, okay, let me write it code here. Let me write a general code here first for you. So let me write it, guys. Mm, this case, I less than 0, j less than 0. You can see it here. Uh, the j greater than of grid size means see what I'll write a base case is see check it out here. It's the same code I wrote in my coding platform. See check it here. This is the base case, right? See See, this is a base case, right? If means if let me compare this one with here. Mm, yeah, yeah. So here DFS of ij means if we give 0, 0, it will go to here, right? Means DFS of 0, comma 0 means DFS of 0, comma 0, right? So let me code it out here. DFS of 0, comma 0. Okay, right? Now uh, check if I less than 0, j greater than 0, j less than 0. If it is I less than 0 or j less than 0, or I greater than or equal to grid dot size, or j greater than or equal to grid dot size, or grid I comma j equal to 0. Remove this base case. See, we gave here 0 comma 0, right? See, this matrix. Let me put this matrix here so you can get it properly. Mhm. Yeah. So see, we gave here 0 comma 0, right? 0 comma 0 means this one, this one. Now we have to travel everything and tell the what we call area of it. That's the reverse call I'm making. Tell the area means just tell the number of unselect. So DFS of 0, 0 means here what will make the call? DFS of 0, 0, right? We'll make the call DFS of 0. Return DFS of 0, 0. Return means it will return number of one unselect. So DFS call, what is the function here? This is the function I wrote, right? DFS of remove this index. I is there, J is there. I means 0, J means 0. Okay, it is the grid. Vector means grid. I gave past grid here. See, DFS of 0, 0. What is the base case now? I'll write the base case here. DFS of 0, 0. If I comma j is less than 1, if I comma j is less than 0, if I is negative, it's not possible, right? If I is positive, it's not possible, right? If I it if I if j is 0, if j less than 0, it's negative, not possible, right? If I greater than n, it's greater than or equal to n. N means the box size, this box size, n cross n, right? Then also it's not possible, right? J greater than or equal to n, then also it's not j greater than or equal to n, okay? Then also it's not possible, right? Now what we'll do is, if it hits anything here, means I'm writing the if case here based on that only, this if case. Understand, guys, this if case. If it hits anything here, I less than 0 or j less than 0, not possible. I greater than grid size, j greater than grid size. If it hits any condition here, return 0, right? Means I less than 0, j less than 0 means there is nothing there, right? Means there is nothing there. So it returns 0. But 0, 0 is there, it's not a base case, right? Here 0, 0, it's not, is it the base case? No. So if DFS of 0, 0 is there, it will go here. It will check grid I comma j equal index, remove this line. Int a means what? Int a means some integer I'm storing is equal to DFS of index I plus 1 comma j. I plus 1 means what? DFS of 0 plus 1. DFS of 0 plus 1 means DFS of 1. Are you getting my point? B means j plus 1. C means I minus 1. D means j minus 1. Four calls, four recursion calls. DFS 1, 0. DFS of 0, 1. DFS of minus 1, 0. DFS of 0 comma minus 1. Now recursion call will go, right. 1 comma 0 means what? Again 4 calls. DFS of 2 comma 0. Ala 4 calls, right? 2 comma, sorry, 1 comma 0, 1 comma 1. Like that 4 calls. Now check here. It runs 4 calls, it returns back. It runs, no, it goes here, goes here, goes here, checks. It returns back. Anywhere it should return back. Now it goes here, it returns back. Now it goes here, returns back, returns back. 4 conditions, right? 2 comma 6 like that. Now after this one, this returns back. See, this one completed, this one completed. Now check this one, guys. DP of minus 1. Is it exists? No, right? So that's why base case here, there. What is base case? I less than 0, j less than 0, return 0. So what will return? It will return 0, right? Means the thing is there, so no island. No island, right? So 0. Basic recursion call, guys. DFS of ij means it find out the, see, suppose box is there. Here one box, here one box, here one box, here one box. Suppose I J is the index. Now, number of islands this has means this is equal to this means if it is one means if here it is one means this is island, at least one island. One plus number of islands this has plus this has plus this has plus this has, right? A, B, C, D, right? Number of islands this box has means if this box is then DFS, number of islands this box has means number of islands this one has means one plus number of islands this one has plus this one has plus this one has plus this one has, right? So 1 plus A plus B plus C plus D. So that's it, guys. That's it for today, guys. I hope you understand it. If you didn't understand it, uh, we'll do. Uh, you can watch it again. So I will do this question in the next video. So that's it for today, guys.